Okay, good morning, everybody. So, let us begin with week 6 of our session. So, in this week, we learned about uh, polymorphism. This week was mainly about polymorphism. So, in the first part, we learned about typecasting. Okay, and the problems that we can face in typecasting. In part 2, we learned about static and dynamic binding of member functions. In part 3, we learned about abstract base classes, and part 4 and part 5 they were about they were mainly about a uh, example application of polymorphism. Like sir used polymorphism in a realistic setting to uh, like sir demonstrated the use of polymorphism using a realistic project, which was this staff salary processing. So, firstly, what is typecasting? So, typecasting is when you convert one type to some other type. So, casting is performed when a value of one type is used in place of some other type. So, converting an expression of a given type into another type is known as typecasting. So, let us say that you have a double value. Let us say 3.2, and in some function you require an integer. So if you convert this double to integer, then this process is called typecasting. Similarly, if you have a integer and you convert it into a double, okay, this is also typecasting. So what are the things that you have to be careful about? So one thing is that typecasting is safe for promotion. When you promote a variable, so when you convert from a smaller type such as this int to double, so when you convert from a smaller type to a larger type, okay, then typecasting is safe because no data is lost in the process. Okay, but typecasting is unsafe when you so typecasting is unsafe for demotion because it may lead to loss of data. So for example, if you convert double to int, then what happens is that someday this 0.2 part, this is lost, so the fractional part is lost. There is no way to recover it, so that is why this is unsafe. Like it is unsafe, but sometimes your application requires you to convert doubles to floats. Okay, so your application might require you to do this unsafe typecasting, but you have to be careful when you do it. Okay, next thing is that implicit casting between different pointer types is not allowed. So basically, so one more thing is that what is implicit and what is explicit casting. So implicit casting is when the variable is converted from one type to another automatically. Okay, let us say that you write something like this: int x equal to 3, then you write double d equal to x. Okay, so this d variable, this is a double, but your x variable is a int. But when you assign uh, x to d, this integer is automatically converted into a double. So this is called implicit casting. Okay, but if you explicitly convert from one type to another, let us say that uh, you you manually specify the conversion, then this is called explicit casting. So this points here states that implicit casting between different pointer types is not allowed. So basically that if you have so it means that if you have a int star p pointer, and you have a double star pointer, double star, you cannot do q equal to p. Okay, this will not work automatically. Okay, you can, of course you can write q equal to uh, double double star p. Okay, you can write this. Okay, this explicit casting is allowed, but the implicit one is not allowed. The next thing is that any pointer can be implicitly cast to void star with loss of type, but void star cannot be implicitly cast to any pointer type. So in this case, if you are this was a void pointer, then this would be allowed. Then this would work. Okay, you can write q equal to p, but you cannot do the opposite conversion. Okay, I mean that you cannot do p equal to q. This will not work. Then we have implicit casting between pointer type and numerical type is not allowed. So you cannot, you know that all pointers, like if you consider a 64-bit machine, then all the pointers, they are 64-bit integers. Okay, but it does not mean that you can convert a 64-bit integer into a pointer implicitly. So this p, this is a 64-bit integer. Now you might have another 64-bit integer, okay, lying around, but you cannot implicitly assign it like this. Okay, it is, you have to explicitly convert. So the last point states that uh, care must be taken when we perform this conversion. Let us say that we convert a pointer type to any number, okay, like any 64-bit number or 64-bit number into some other thing. Then you must take care that the integral type is of the same size as the pointer. Okay, so do not typecast a pointer into a 16-bit integer, because it won't fit, right? A 64-bit number will not fit into a 16-bit number, and it will lead to loss of data, and you will not be able to recover that data later on. So the next topic is static and dynamic binding. So mainly the difference is that, okay, firstly, what is binding? So you will see that in C++ actually, in so firstly in C, when we write a function, okay, let us say that, sorry, in C, in the C language, when we define a function like this, okay, so that definition is unique, okay, because nowhere else in your code you can uh, define another function of the same name. Okay, you cannot write func again. So that definition is unique, and it is very easy to identify that somewhere else in your code, if you write func, then it is very easy to identify that which function will be called. But in C++, it is not so straightforward, because as you know that there are many complicated ways to define functions. You can do um, function overloading, overriding, okay, and you can have classes, objects, okay, so static functions, many things are there. So it is not really straightforward that if you, in some piece of code, if you write a function, then which function will be called. So this assignment of this function assignment, okay, so this is known as binding. uh, so you can see binding is basically when the function invocation is connected to the function definition. So in your code, if you write a function somewhere, So that function invocation has to be connected to the function definition, and this thing is called binding. Now there are two kinds of binding, one is static and one is dynamic. So static binding means that, mainly if you see, static binding means that it is done at compile time, and dynamic binding it is done at runtime. So it is done at runtime. So you can read the point here. The static binding is when a function invocation binds to the function definition based on the static type of object. So this is done at compile time, and normal function calls, overloaded function calls, and overloaded operators are examples of static binding. So what happens is that the compiler sees the data type. The compiler sees the data type of the arguments. It sees the return type of the function. Okay, and then it figures out that which function to call. Okay, and you can do this thing in during compilation process. So uh, like there is no additional system required. While compiling the program only, you can figure out that based on the type of the arguments or the return type, what should be the uh, which function should it be bind to. Okay, so you can see that normal function calls, or if you overload functions, or if you overload operators, then these are examples of static binding. Now the next thing is dynamic binding. So in dynamic binding is when a uh, function invocation binds to the function definition based on the dynamic type of objects. Okay, and this is done at runtime. So basically when the program is running, okay, when the program is running, uh, then the program checks that which is the correct function to call based on the current scenario. So the examples are function pointers and virtual functions. So function pointers and virtual functions, they are examples of dynamic binding. And dynamic binding is possible only for pointer and reference data types, and for member functions that are declared as virtual in the base class. These are called as virtual functions. Okay, so the next topic is that abstract base class. So what is this abstract base class? It is a class containing at least one pure virtual function. Now what is this pure virtual function? So in the previous slide we learnt about this static and dynamic binding, and there was a keyword here, virtual functions. So basically, if you have a base class, and in this base class you define this in the base class, let us say that you define a virtual function. I am writing VIRT, so you define a virtual function f. Okay, and you create a derived class here. So what will happen is that when you create an object of the derived class, but you assign it a base pointer, so you you do create a new object of the derived type, but you assign it to a base pointer. So okay, let us say you do this, and then you write b dot f. So during normal, static binding, what happens is that since the this object is assigned to a base pointer, it will call the function in the base class. Okay, this function. But since this is a virtual function, what will happen is that it will call the function, it will call the corresponding function of the derived class. Okay, so this is the example of dynamic binding. So a pure virtual function is a function in the base class which has no function definition. So the body of the function is not defined. So how do you write it? You basically uh, you write virtual and then the usual function definition, and then you write equal to 0, and then you do not define the body. The body of the function is not defined, and the virtual keyword is there, and then it is assigned equal to 0. So this is a pure virtual function, and it is pure because there is no body in the function. Pure virtual function may be inherited or defined in the class, and no instance can be created of an abstract uh, base class, and naturally it may not have a constructor or a virtual destructor. So since the uh, so in a way you can think like this. So abstract base class is like a template. So abstract base class is like a template. It defines that what functions should the class have. Okay, what functions it should have, but it does not necessarily define or implement those functions. It just says that it should have these functions, and when some other class it this derives from this abstract base class, its purpose is to implement those virtual functions. So since the abstract base class is kind of incomplete, so it is kind of incomplete because the function definition is not provided. So since it is incomplete, you cannot create any objects of the class, obviously. Okay, because if you could create objects, then you can call the function, right? But the function is not defined. So, so that is it. Now we'll move on to the questions. So this is the first question. Please try on your own. Okay, now let me discuss the solution. So, uh, see, in this question we have a class A, and then we have a class B which derives from class A. Okay, so B derives from class A. Next, you can see that in class A we have a normal function fun1, and then we have a virtual function fun2. Okay, and then in the derived class uh, we are overriding both the functions. Okay, sorry, we are yes, so we are overloading both the functions fun1 and fun2. Okay, so this is what we are doing. Now in the coming to the main class, I mean the main function, you can see that we are creating a object of the new of the class B type. So we are creating an object of the class B type, but we are assigning it to a class A pointer. So this class B object is being assigned to this A object. So since the B is derived from A, so you can think like this, that B contains a small version of A. So this A object will be there, and then it will have some extra things. Okay, and this whole thing will be now called as B, right? That is what happens in inheritance, function inheritance. And now this pointer is there, so pointer T, okay, variable T, it points to the beginning of this object, and so points to the beginning of this object. Now if this pointer was of class B type, let us say that this pointer was like this, then this region of the memory will be interpreted as a B object, right? But that is not the case. Instead, what is there is that it is of A type. So this region of the memory is interpreted as a A object. Okay, only the beginning of this object is considered. So that is there. Now when I call T arrow fun1, okay, when I call T arrow fun1, then since it is of this A type, it will call the fun1 function of A. Okay, so this function will be called because it is of A type, and it is a normal function, it is not a virtual function. So this will print 1, okay, like that. Next I call T arrow fun2. Now fun2 is a virtual function, so since fun2 is a virtual function, uh, it will have this what dynamic binding, and it will have this dynamic binding, and the actual function will be like the binding will happen based on the actual type of the object. So we know that this T pointer, although it is of type A, okay, although it is of type A, we know that it is actually pointing to a B type object, right? So since we know that it is actually pointing to a B type object, the binding will take place based on the actual type, and it will happen at runtime only. So based on the actual type, the fun2 of B should be called. Okay, so this function should be called fun2 of B. So this will print 4. Okay, so because of this, the output will be 1 4. Okay, okay. Now I'm moving on to the next question. This is the next question. Please try on your own. Okay, so now before I proceed, there is a question in the chat box that how is the answer 14? So actually 1 and 4 will be printed and there is no space between them, so that is why the answer becomes 14. I hope it's clear. I mean, it is 1 and 4 and there is no space, so that is how. Anyway, moving to the second question. So moving to the second question. So okay, now in this question again we have the same scenario. So we have this A class and we have the B class, and then B derives from A. Now you can see that in class A it has a virtual function called fun, which prints class 1. In B we are overriding that function and we are printing class 2. Next we have the main function. In the main function we are creating a object called t1 of class B type, and then we are creating two pointers t2 and t3 of class A type. Okay, and t2 is assigned to a new B object and t3 is assigned to the address of t1, and then we are calling the fun function of both of these objects. Now this in this question also it is quite simple, because you can see that this fun function, this is a virtual function. So again the binding of this function will take place dynamically during runtime. So what I mean by dynamically is that it will happen based on the actual type of the object and not the type that not the type of the pointer. So if you see, then you have an object called t1 which is of B type, and then you have another object also of B type. So now t2 is pointing to this new object and t3 is pointing to the address of this t1 object. Okay, and then you are calling fun of both the objects. Now t2 and t3, they are both of A star type. So like logically, like in if you had static, if you had normal functions or static binding, then t2 and t3 would call the A's fun function. Okay, so I can also draw a table here. So if this was static binding, then it would print class 1 and again class 1, because both the pointers are of A type, so it will call A's function and A's function prints class 1. But in this case it is a virtual function and dynamic typing will happen, dynamic binding will happen. So it will use the actual type of the object to print. So B's fun will be called and it will print class 2 and class 2. So finally your answer is class 2 and class 2. Okay, so I need to proceed to the next question. So this is the next question. Please try on your own. Okay, now let us discuss this question. So in this question, the situation is like this. Again, we have this base class, and then we have the derived class, which derives from base. Next, you will see that we have a global variable x, which is initialized as 0. Okay, so we have the global variable x, which is initialized as 0. Next, we have the base class and the derived class definition, and then we have a global function here, and then the main function. So again, so this is a global function. So we have this global variable x. Next, you will see that both the base class and the derived class, they have these constructors and destructors. Okay, so their constructors and destructors have been defined. Okay, it's not the default one. And in the base class constructor, we increment x by 3. In the destructor, we decrement it by 5. In the derived class, we increment it by 7, and then we decrement it by 1. Next, in the fun function, you will see that in fun function we create a object of the derived class called t. We create another object of the derived class, but we assign it to this base class pointer. Okay, we create another object of the derived class and we assign it to the base class pointer t1, and then we print the value of x, and at the end we delete this t1. So t1 is a pointer, we delete the t1. And now in the main function we so in the main function we call this fun function, and then we print the value of x. So what will be the output? So in the main function we first call fun. So basically, like, we can now go to the fun function. So in the fun function, first we are creating an object of the derived class. So basically the constructor of derived will be called. Now since derived is derived from base, so first the base object will be constructed. So first the base object will be constructed, and then surrounding it the derived object will be constructed. So in the base constructor, x is incremented by 3. So and x is initially 0. So let me write here a table. So initially x equal to 0. Then the base constructor is called. Base constructor is called. Now x is 3. So the base object is constructed. Now the derived object will be constructed. And in the derived one, x is incremented by 7. So x is now 10. Okay. Yeah. After the first line of fun, x is now 10. Next, we are creating another derived object here. Okay, we are creating another derived object. So again, the same procedure will follow. Okay, so the same procedure will follow here. And now we are printing x. So since x is now 20, so 20 will be printed. And then we are calling delete t1. Now note here that t1 is of the type base star. Okay, so it is base star t1. So T1 is of the type base star, and you have to see that this your base star and this derived star, they are not virtual functions. Okay, so I mean, since they are not virtual functions, so the and since this is T1, so this base destructor will be called. Base destructor, it decrements it by 5, so x is now 15. Now you will see one. Now notice one thing, that we are now at the end of the function. Okay, we are at the end of the function, and at the end of the function, all the local variables are deleted. So this first variable, which is t, small t, that variable will also be deleted. But that variable t is of the derived type. So the derived destructor will be called, which decrements it by 1. Wait a minute. Okay, the derived destructor will be called, but the derived destructor will first call the base destructor. Okay, so the first the base will be destroyed, and then the derived will be destroyed. So the base destructor, it decrements it by 5 again, and finally the derived destructor is called, which decrements it by 1. So finally x is 9. So after it exits from the fun function, your we can print the value of x again. It will come out as 9. So the answer will be 20 and 9. Okay, I hope this is clear. You can note down the this table that I have made. Okay. Okay, now let me proceed to the next question. So this is the next question. Please try on your own. Okay, now let us discuss the solution to this question. So in this question again we will draw the class diagram here. So the class diagram is somewhat like this. Okay, your A class is there, then your B class derives from A class, and C class derives from B class, and then all the constructors and destructors they have been overloaded to print certain values. Okay, like A tilde A, B tilde B, C tilde C. And the key thing in here is that all of these constructors and destructors they are normal except for the last one. So in class C it is a virtual destructor. Next we come to the main function. In the main function we are creating a new object of class C type, but we are assigning it to a class A type pointer. So since the inheritance diagram is like this, you can think that it will look like this, somewhat like this in the memory. Okay, and your T1 points here, and T1 is of this class A style. Okay, now let us go over the first line. So in the first line, since this uh, object of class C is being constructed, so the class C constructed will be called. But before that, since it derives from class B constructor will be called. And again before that, since class B derives from class A constructed will also be called. So because of this, the sequence will be like this: first A will be constructed, then B will be constructed, and then C will be constructed. Okay, so like this all the constructors will take place. So after your first line your output will look like this. Okay, ABC. Now next we are deleting T1. Okay, now here the thing is that your destructor is virtual, but it is assigned to class C. So in class C your destructor is virtual, but in class A and B the destructors are normal. Okay, they are not virtual. So and now since T1 is of this class A type, okay, so when you call its destructor, the A destructor will be called. So this will be the output. Okay, ABC and tilde A. So ABC is because of like making this C type object, ABC will be called. Now and when you call T1, then uh, since T1 is of class A type, it will be destroyed, and we will call the destructor like this. Okay, I hope this is clear. Moving on to the next question. So this is the next question. Please try on your own. Okay, now let us discuss the solution to this question. So in this question, you can see that again we have a base class and we have a derived class, and your derived class, it derives from the base class. Now coming to the base class, so this is the base class, this is the derived class, and this is the main function. And coming to the base class, you will see that it has a integer a, okay, and then it has a constructor called base, which takes an integer I and it assigns it to a. So I is assigned to a. Next you will see that it has a virtual function called test, which takes a base star pointer as input and it prints a. So it takes a base star pointer as input. It does nothing with the pointer, but it prints a. Now coming to the derived class. In the derived class, you will see that it has a integer called b, and it has an integer called b, and it has a constructor called derived, which takes two arguments I and j, and it assigns I. It uses I to construct the base, and it uses j to initialize b. Now if you come to the base class constructor, then you know that I is assigned to a. So this derived class constructor, in a way it assigns I to a and j to b. Okay. Next week, the derived class, it also has a function called test, which takes a derived star as input and it prints b. Okay, so instead of printing a in the base class, you can see that it printed a. In the derived class, instead it prints b. Okay, and the other thing is that one more thing, the argument type is also different. In the base class, it takes a base star pointer. In the derived class, it takes a derived star pointer. Okay, now we come to the main function. In the main function, it has like we create a new derived object using 5, 9. So here we saw that I is assigned to a and j is assigned to b, right? So basically after this line, what we get is a equal to 5 and b equal to 9, equal to 5 and b equal to 9. Next what we see is that this derived object, it is assigned to this base star pointer t1. Next we call t1 arrow test, okay, and we call it with this new derived thing. Okay, so now one thing you have to understand here. Okay, so this is actually not as simple as it looks. Okay, so the thing here is that this function test, although it is a virtual function, okay, this test function, it takes an argument of base star, and then when you come to the derived function, this test function, it takes the argument of derived star. So these two functions, they are not really the same. One takes the argument of base star and the other takes the argument of derived star. Okay, so they are not really the same. So even though your function test function is a virtual, it will not be overloaded in the base derived class. Why? Uh, because these functions are not the same really, so there is no overloading taking place, no overriding taking place. So when you call this t1 arrow test, it calls this function, okay, it calls the test function of the base class, calls the test function of the base class. Now here in the argument, when you write new derived, okay, uh, it creates a derived star object and it creates a pointer, okay, to a derived object. But your test function here, it takes a base object pointer, okay. So in this case, what happens is that the derived object is implicitly typecasted to this base object. Okay, so the derived object is when a derived object is implicitly typecasted to base, and this test function of the base class is called, and this function prints a, and you saw here that a was 5, so 5 is printed, so the output is 5. Okay, I hope that was clear. Okay, then now we move on to the next question. Okay, now let us discuss this question. So in this question again, so one thing you will notice here that there is no virtual function here. There is no virtual function here, and therefore uh, no dynamic binding. Again, the class diagram is like this. Your A class is there, and your B class is there, which derives from A class. The A class it prints A, your B class prints B. Both have the function called print, and in A class your print takes no argument, but in your B class your print takes one double argument. Next we come to the main function. In the main function we create an object of type B. Okay, then we call t1 dot print without any arguments, and then we call t1 dot print with a double argument, and we want the output to be A and B. So basically we want to first call this print, and then we want to call this print. So first we want to call A's print, then we want to call B's print. So doing that is quite simple. So one thing you know is that uh, when you write a function of the same name, okay, then in the derived class, if you write a function of the same name, then the corresponding functions of the base class, they are hidden from the derived class. Okay, you know that. So to make those functions again reappear in the derived class, you have to use the using keyword. Using a colon colon print. Okay, so if we write that, then this function will come in the B class also, and so this one takes no argument, this one takes one argument, so both of these function calls will work, and they will print A and B correspondingly. Okay, so then this is the solution using A colon colon print. I I hope it was clear. Okay, then let us move on to the next question. Okay, so this is the next question. Please try on your own. Okay, now let us discuss the solution to this question. Wait a minute. Hmm. So, in this question, uh, you can see that there are three classes. Okay, class A, class B, and class C, and all three have some public data members. Okay. Now, one thing you will notice is that none of the classes they inherit from each other. Okay, so there is no inheritance between A, B, or C. Next is that you have A star pointer P, then you have a B object P1, and you have a C object P2. Next, what you do is that you take this P1 object which is of B type and you typecast it to A star. Okay, typecast it to A star, and then you call P arrow A, and then again what you do is you take the T2 object and you typecast it to A star, and you now call P arrow A again. Okay, so what will be the output? So one thing is that you have this B object, okay, which is of, so if you see the B object, then excuse me, wait a minute, wait a minute. Hmm. So, so this question is actually about typecasting and not inheritance. Okay. So what are the memory layouts of, you have to see what are the memory layouts of A, B, and C. So in your A object you have this small a equal to 5. So this is your memory layout. In your D object you have this. Okay, one more thing. This is an integer also. Okay, so these are the memory layouts of the three classes A, B, and C. Now, so in this line, okay, so in this line, basically we are typecasting a B type object into an A type object. So if you see, if you do that, then what happens is that since the memory layout of both the objects A and B, they're actually the same only. They have one integer. So when you do that, and then you write P arrow A, uh, the memory layout will give out a normal value. Okay, it will give out 9. So you see that in class A your int A is 5. Okay, so if you for a normal A type object, if you write P arrow A, then it should print 5. But since you are typecasting this B type object into A and the memory layout is the same, so in this case P arrow A should print 9. Okay, so this line will print out 9. This line will print out 9. Now coming to the next line, Okay, in the next line we are converting a C type object into a A type object. This case the conversion is not straightforward, because you see that this is a double, okay, this object is a double object, and you are converting it to a int type object. Okay, so since the memory layout is not the same, the conversion will not take place smoothly, and your p arrow a will give out some garbage value. Okay, so in the first case the conversion is successful and it gives 9 instead of 5, but in the second case it gives a garbage value because the memory layout is not the same. Okay, so I hope that is clear. Now let me move on to the next question. This is the next question, please try on your own. Okay, now let us discuss this question. So in this question, we are told to identify the abstract classes. So this is a quite simple question. So we just have to identify which are the abstract classes. Now remember that abstract class has a pure virtual function. So So of course, pure virtual. So how do you identify a pure virtual function? Is it will start with the virtual keyword, and there will be the uh, function, and then I mean the signature function signature, and then it will be equal to 0. So that is how you identify. So now let us see the vehicle class. Okay, this is the vehicle class. This is the car class. This is the motorcycle class. Okay. And similarly here this is the truck class, this is the sports car class, and this is the SUV class. Now let us look at the vehicle class. Okay, you can see that there are two pure virtual functions. So of course this is a abstract class. Next you see that the car class, it inherits from the vehicle class, but it does not override any of these pure virtual classes. Okay, it does not provide any implementation. So the pure virtual functions will also be there in the car class, right? So that is why your car class is also abstract class. Next we come to the motorcycle class, which inherits from the vehicle class. In the motorcycle class also you will see that it does. Okay, so in the motorcycle class you will see that it provides the implementation for the run function. Okay, that provides the implementation for the run function, but the stop function is still not implemented. Okay, it is not yet implemented. So your motorcycle is also a abstract class because the stop implementation is not provided. Next we come to the truck class. Okay, the truck class, you can see that it inherits from the car class, and it provides implementations for both the run and the stop function. And because of that, your since there are no pure virtual functions present in this, okay, your truck is not a abstract class. Your truck is a normal non-abstract class. Next we come to the sports car class. The sports car class, it inherits from the car class. It implements the run and the stop functions. Okay, so in that way it is all right, but then you can see that it creates a new pure virtual function on its own. Okay, and because of this reason, your sports car is also a abstract class because it has one pure virtual function, which is run turbo. Next we come to the SUV class, which inherits from the car class, and you will see that it also provides implementations for the run and the stop functions. Okay, and it does not create any other pure virtual functions on its own. Okay, and because of this, like there are no more pure virtual functions left. So that is why your SUV is also a SUV is not a abstract class. SUV is a normal class. Okay, so finally what we get is that the abstract, let me now list it down. So the abstract classes are your vehicle, and then car, and then motorcycle, and then sports car. Okay, fine. Okay, so that's all for today. So thank you for attending today's class. You may now leave.